So in this session, we talk about network software. In previous classes, we have already discussed what are the network hardware required to make up a network. And coming to the software means set of rules uh, that we deploy in a program. So how these rules are related to computer network means network is not defined like a software or hardware. So it is a combination of software and hardware in order to send the data from one unit or one location to another location. So in order to send the data from one location to another location, both parties should agree on some set of agreements or rules. So if I am talking in English, you should know English and you must be in a position to understand whatever I am delivering. So in this way, we both agreed on a rule called knowing English and talking English, so that we can exchange our data. Similarly, for computers in the network also, both parties at the end, that we call it as host system, should understand what are the protocols to be followed at different places of the data communication. So hardware means physical equipment that we use to carry the signals like copper wires or coaxial cable or fiber optics. All these things are comes under hardware. Now, in case of software generally divided into different pieces in network structure. Actually, if you have a network is not formed like a unit. It is formed like a collection of units. So at which unit you want to do which kind of rules, you want to follow which kind of rules. All these things we define. That we call it as a protocols. Protocols means protocols at different stages of the data communication. Now, if you go to next slide, we make use of a hierarchical approach of this protocols. Like in order to reduce this complexity, if you are building a system like a unit, it is very hard to understand and very hard to debug. And instead of that, we can divide the system into different modules, and then we start the writing rules for each and every module. Similar to the same approach, here also, in order to reduce the complexity of the network, different types of layers are used at a different stages of the network. Okay. So now, in this protocols, these protocols, number of protocols and name of the protocol, all need not to be seen at different models actually. Network to network, this may vary. If you are at wireless network, the protocols to be deployed is different. If it is a wired network, the protocols to be used is maybe different. So this way, we don't have a thumb rule like these are the protocols must in a network design. That depends on the type of the network. So now, in order to make our work very easy, these protocols are divided into different layers. Each layer job is it is going to provide the services to the layers above it. Okay, collecting the data is done by one layer, and compressing the data may be done at one, and reducing the complexity. All these things may done at different layers. Likewise, each layer is acting like a virtual machine to offer the services to the besides layers or neighboring layers. Now, so if you take a general example of regular life activities, if you want to send a letter to a person who are located far away from you, then what approach we will do is we write a letter. It is a step-by-step process. So if you follow this step-by-step process, then only it is possible to deliver a letter to your friend. That is the reason. So what is the job to be done at first layer, and what is the job to be done at second layer, and next. All are defined very clearly. So in this example, if you want to write a letter, first write a letter, put it in an envelope, and then after drop that one in the mailbox. And after that, that letter is carried by from mailbox to the post office, and post office people may give that one to the carrier so that it is going to travel for a longer distances, and the reverse process is approached at the destination site. When you got a letter, again it is carried to carrier, and then after it is reaching the destination, again that person will open the letter and read the contents. So this way, general approach in regular life is going to follow step-by-step process to communicate from one place of the network to the another place of the network. And such kind of things are used in our networking model also. In networking model also, if you want to do a data communication, we need to follow some set of rules. Those rules are again hierarchically organized. So if you see this one, here it is going to project This is one of the model arrays, small model which is having 5 layers inside it. Now, this will show you network architecture, the number of layers present and the protocols existed and the interfaces existed. Combined this we call it as a network architecture. Now, in this example, we have 5 layers. We want to communicate from host 1 to host 2 system, which is located there. Now, every host we take, the layer 1 of host 1 is communicating with layer 5 of host 1 is communicating with layer 5 of host 2. This way, the hosts are communicating. That communication we call it as a virtual communication. But if you observe the solid lines, these solid lines will give you the exact data transfer. I repeat, if you want to communicate from one system to another system, there are different layers at both sides. And always we remember layer 5 of one system is communicating with layer 5 of the other system. But those are not directly communicating. So whatever the dotted lines here we have shown is called as a virtual communication. In order to implement that virtual communication, this layer 5 has to give its content to layer 4. Layer 4 will add its own headers and it is forwarded to layer 3. Likewise, it is going to have a journey towards layer 5. After that, by using physical medium, it is going to traverse the data to the layer 1 of the host 2. Similarly, the same approach whatever we followed here. If layer 1 is making use of a copper wire, if it is making use of one protocol, X protocol, the same X protocol is followed by layer 1 of host 2 also. Likewise, protocols are defined at each and every layer. There is no universal protocol applied to entire network model. Generally, protocols are divided into layers. Actually, whatever the layer we use, there are some set of protocols to be followed. So this way, this 5-layer system architecture is existing. And in coming slide. So now, what is the job of these interfaces at each and every layer? So if you observe this example, it will show you the relation between virtual communication and actual communication. And now, if you want to pass the message from layer 5 of one system to another system, then what happens means layer 5 will send its content, that is M in this case, M is sent to layer 4, and then layer 4 will add some additional information about from which application it is coming and what are the rules followed by that application. All the things we call it as additional information. That additional information is added to the message and again it is forwarded to the down layers. And again in this example especially, layer 3, the job of the layer 3 is to split the messages. If the message is very bigger, then it can split that one into 2. Again, the 2 packets can be sent over the network. So if there is a message called M, which is split into 2 like M1 and M2. M1 is having additional information of H4 and H3, layer 3 additional information, and whereas M2 is having layer 3 additional information only, because already layer 4 additional information is included in first part of the message, that is M1. So that layer 4 information no need to carry in each and every part of the message. So that's the reason. Likewise, a message can be split into different small unit called as a packets, and every packet is added with the control information. Likewise, every layer we take, those layers are going to add additional information related to error control, flow control, or segmentation. All these things are added throughout this journey. And at the same time, whenever it is reaching the other side, this header information is useful in order to gather our information back. So whatever the information is sent from this source, in order to recollect it and recreate it at the receiver side, we make use of the additional information. For example, additional information is giving, we are making use of ASCII code. And accordingly, by using ASCII code only, we are trying to recollect the content. And one of the examples is if you are using optical signals, like that is additional information, which bandwidth we have taken, what is the light source. This is additional. That additional information is taken by the receiver in order to get our data from the signals. So this way, the communication is created between two protocols of 2 layers with the help of actual communication. I repeat, this will show you the implementation or relation between virtual and actual communication. So this way, it is going to work. And now, coming to design issues of this network layers, whatever the network model we use, it should follow some set of layers. And layered approach, that depends. You may have 3 layers, you may have 4 layers, or whatever it may be. But all layers should include the functionalities required for the communication. So, in this sense, every layer we take, those should follow some sort of design issues. Those are these. First one is addressing. Addressing in the sense, every node in the network should be addressed. Like there should be an identity to each and every node present in the network. So addressing scheme must be existed, like a logical addressing or physical addressing, that should be defined by the layer, network layer. So this is the one issue to be addressed in network layer design. Addressing should be existed. Every node should have some address, maybe logical address or physical address. Logical address is used when the data is moving over the network. Physical address is used when you are part of the system. When you are working at some system, we always take the physical address. And similarly, when data is error control is one of the major issue to be taken care in network layer design. Error control in the sense, when the data is moving through the network, there may be a lot of disturbance in the medium, like noise generation, or there may be electrical disturbances to the medium, so that it is going to add noise to the data what we have sent. And the job of the network layer protocols is to identify whether the data sent by the sender is same, or is there any additional noise added. If there is any additional noise, identify where is the mistake, and that should be recovered. That we call it as error control and error detection techniques. That should be addressed in any of the network layers. And there is one more thing called flow control. Meaning of this one is, when there are two systems, in general network means it is a collection of nodes. The nodes need not to be homogeneous configuration. You may have a different configured systems. Different configured system in the sense, I may have I5 system, you may have I4 system. So that if you send the data with a higher speed, like I have a lot of bandwidth, I have very good internet connection, and you have very less, like you are working on mobile. In that cases, whatever the data I send with my speed may not reach you because you are having very less speed configuration. In that cases, there should not be loss of data in the middle. So that should be taken care by the flow control mechanism. This is one of the job of the layers. And there is one more thing called multiplexing and demultiplexing. Like it is not possible to have connection between each and every system, like a mesh topology. So what we are trying to do is, we have only one line, and on that line multiple systems are working. So there should be a way to merge our data onto the same line. So you don't have separate line for your data. So if there is a network, there are many people connected to that network, and then, so if there is only one channel, the channel means the medium used for transfer the data from one place to another place. In that case, if you have only one line with a bandwidth of 100 Mbps, then our entire data, see, from my system, many applications are running, data from Gmail, data from Output, or data from Facebook, data from WhatsApp. This data has to be merged, and that is pushed onto the same line. Likewise, multiplexing has to be done, and demultiplexing in the sense, again, get back your data to individual applications. If I send a WhatsApp message from my system, you should get that message in WhatsApp only, not in another app. So that we call it as demultiplexing. How you are getting back your data, and how you are merging your data into one message. And those things should be addressed when you start designing a layers. And the most important thing is routing. The name itself indicating routing, in the sense, route the packet in a proper way to reach the destination. So there should be a layer responsible for identifying the destination and delivering the packet sent from the source to the destination. That layer should take the entire responsibility of taking the data from the source and reach the intermediate nodes, and then after next intermediate node towards destination. Likewise, your data should move from source to destination in a optimized path. Why I say optimized means, nowadays we don't have a simple structure like this. It is not bus structure, or it is not ring structure. Like we are in a mesh network, you may have multiple paths between one system and another system. If you have multiple paths, then among the multiple paths, which path we need to select for the data transfer has to be taken care by the routing tool. There are many routing protocols. Those protocols we look after to find out the best or optimal path to transfer your content from source to destination.